This is Pam Oakes, ASE Master Technician and Automotive Applications Engineer, welcoming you to this edition of Nissan's Expert, Unlocking Insights with Pressure and Temperature Gauges. A quick note before we begin. Every repair is unique, and no two challenges are exactly alike. We're not suggesting you must use every technique presented in this course. Rather, we encourage you to consider which methods may complement your own diagnostic and repair process. In this edition, we'll explore the fine art of pressure-temperature diagnostics, also known as thermodynamics. My goal is to give you the practical information you need in the bay, especially when working with HVAC systems and understanding how these factors interact. Let's get started. These four sections work together symbiotically, and their interaction is essential for the AC system to operate at peak performance. This is the automotive AC loop. And here are the possible loop configurations: an expansion valve system and an accumulator system, both of which can be used in dual evaporator and/or dual compressor setups, as well as heat pump systems. No matter which loop design a vehicle uses, expansion valve, accumulator, dual evaporator, or heat pump, the stag pressure check is always the first step in evaluating the refrigerant system's overall health. And let's be honest, you don't want to calculate ambient temperature and elevation for every vehicle that comes into the shop. That's why we use the FIX, a thermodynamically correct calculator. It will display slightly lower gauge readings, manifold attached to a vehicle, at higher elevations for the same ambient temperature, but in automotive. We keep things simple. Instead of sitting there doing equations every time a vehicle rolls in, we use reliable charts and tools that turn all that thermodynamic math into quick, accurate gauge readings. It gives us a solid baseline right away, so we can focus on what really matters, the diagnostic work that follows. And to make it even easier, here's an app that gets you right in the ballpark for proper manifold gauge readings based on temperature and your location anywhere on the globe. Another often overlooked step is simply to look and listen. Check for visual clues that point to leaks or physical damage, and use your trained ear to pick up any unusual sounds while the system is running. How much is too much? That's the question we all run into sooner or later. When it comes to refrigerant and oil quantities, guessing is the fastest way to turn a simple job into a comeback. So instead of rolling the dice, grab your phone and scan this QR code. It'll take you straight to Nissan's Oil and Gas Finder, your shortcut to the correct AC refrigerant and oil specs for the exact vehicle you're working on. No digging, no outdated charts, no second guessing. Just solid, accurate info right when you need it. An AC system depends on both high and low pressures and temperatures to keep the loop moving. Since pressure and temperature rise and fall together, the refrigerant changes state at its saturation point. The high side releases heat and builds pressure, while the low side drops pressure so the refrigerant can absorb heat before returning to the compressor. In an expansion valve AC loop, the refrigerant changes pressure and temperature as it moves through each component. It leaves the compressor hot, cools in the condenser, stabilizes in the receiver dryer, drops sharply at the expansion valve, and absorbs heat in the evaporator before heading back to the compressor. In an accumulator AC loop, the refrigerant cools in the evaporator, gathers in the accumulator, then heads to the compressor. After heating in the condenser, it passes through the orifice tube, drops in pressure, and starts the cooling cycle again. Your manifold gauges are your first line of insight into what the AC system is doing. Just this kit, you can read high and low pressures, verify system balance, pull a vacuum, or charge refrigerant, even when the shop's RRR machine is tied up or down for repair. AC diagnosis still starts with a pressure check, but modern compressors make things trickier because they constantly adjust pressure based on the car's computer. That's why today you need temperature readings too. The combination of pressure and temperature is what truly reveals the system's condition. The condenser fan pulls in outside air through the front grill and pushes it across the condenser to remove heat. Since it's electrically driven, the fan can be activated in several ways depending on the vehicle's control system. Refrigerant enters the condenser from the compressor as hot vapor. As it moves through the coils, it cools and turns into a liquid. Airflow, whether from the fan or the car's movement, is what makes this condensation possible. The refrigerant loses 20 to 50% of its heat with almost no pressure drop, leaving the condenser as a cooler, high-pressure liquid. Checking the condenser's inlet and outlet temperatures gives you a quick read on system health. The inlet should run around 140 to 195 degrees Fahrenheit, and the outlet no higher than 140 degrees Fahrenheit. Higher temps point to issues like weak airflow, blockage, contamination, or even an overcharged system. Low too high and high side too high could be an indication that the condenser is partially blocked, contaminated, or an ECV MCV is going into failure. AC compressors come in three main designs: piston, rotary vane, and scroll. Each can be fixed or variable displacement and may use a clutch or an external control valve. Knowing the type helps you understand how the system regulates pressure and cooling performance. The high side inability to shed heat and builds pressure, while the low side rises pressure so the refrigerant cannot absorb heat again, could be a sign that the high and low side hoses are crossed, or the ECV is defective. In newer AC systems with ECV compressors, the wrong refrigerant amount hurts lubrication. That's why having the correct charge is critical to keeping the compressor healthy. And too much lubricant, or the wrong kind, like moisture, will eventually take out a compressor by overheating it. That's why technicians need to be precise and careful with every AC service procedure they perform. And additives are fine when used as directed. But overusing them, or using the wrong type, can quickly lead to compressor problems. A drive belt only works when it's properly tensioned. Older cars needed manual adjustment, but most modern vehicles use self-adjusting tensioners. You don't always replace the tensioner with the belt, only if it's worn or seizing, often heard as a rattling noise. Sane gauge pressures, high and low, could be caused by a belt pulley malfunction. The expansion valve regulates refrigerant flow using opposing pressures. As refrigerant leaves the evaporator, it warms the sensing element, causing the diaphragm's fluid to expand and lift the pin opening the valve. Meanwhile, outlet pressure and the spring push back, creating a balance that meters the right amount of refrigerant into the evaporator. Inside the orifice tube, the refrigerant is pushed through a tiny restriction, creating the pressure and temperature drop needed before it enters the evaporator. The flow is controlled by the pressure difference across the orifice, and fine gauze filters on both ends help keep debris out of the evaporator. When you measure temperature directly on the expansion valve, you should see about 35 to 41 degrees Fahrenheit. You want no more than a 5-degree difference between the inlet and outlet tubes. Anything above 46 degrees Fahrenheit signals trouble, usually poor lubrication, restricted condenser or dryer flow, fan issues, or the wrong refrigerant amount. In short, a high reading here points to system inefficiency that needs attention. Low side too low, high side too high. An AC system only works because it constantly balances high and low pressures and temperatures. Pressure and temperature rise and fall together, and the point where the refrigerant boils or condenses, its saturation temperature drives the whole process. Check for expansion valve issues such as restriction. Expansion devices are precise components and extremely sensitive to any impurities in the AC system. If one becomes blocked, it can quickly lead to serious system problems, including poor cooling and compressor damage. If the evaporator or expansion valve freezes, the refrigerant can't properly change from liquid to gas. That sends liquid refrigerant back to the compressor's suction side, something that can quickly damage or destroy the compressor. Receiver dryer desiccants come in different types, and choosing the right one matters. XH7 and XH9 work well with R134A and shouldn't be used when retrofitting to R456A. For that, XH11 is required since other desiccants can break down or lose efficiency. When you measure temperature directly on the receiver dryer, you want to see 86 to 122 degrees Fahrenheit. Anything hotter signals trouble. Poor airflow, blockages, bad refrigerant, or even fan issues. High temperature here usually means high system pressure, which can quickly put the compressor at risk. The receiver dryer should be replaced every 2 years or anytime the AC system is opened. Its desiccant and filters wear out over time, and moisture entering the system quickly ruins its ability to protect the loop from contamination. As the refrigerant leaves the evaporator, it's a mix of liquid and vapor. The accumulator collects any leftover liquid, lets it slowly evaporate, and only sends vapor to the compressor. Liquid entering the compressor is catastrophic. It can destroy it instantly. A refrigerant enters the evaporator as a cold, low-pressure liquid. As warm cabin air blows across the fins, heat transfers into the refrigerant, cooling the air before it's pushed back inside by the blower. With enough heat, the refrigerant fully vaporizes, while moisture from the air condenses on the fins and drains away. When checking temperature directly on the evaporator, the sweet spot is 32 to 41 degrees Fahrenheit. If it drops below freezing, you may have moisture, air, or contaminated refrigerant in the system. Temperatures above 46 degrees Fahrenheit point to airflow issues, poor lubrication, or incorrect refrigerant levels. Warm air from an ill-fitting aftermarket evaporator core can skew manifold readings when unmetered blower air bypasses the core's fins. Dust, reeves, insects, and mold can easily clog the evaporator's thin fins and tight gaps, cutting its ability to exchange heat. When the surface gets blocked, the system can't cool properly, and the compressor can end up seriously damaged as a result. Too much oil in the system leaves no room for proper evaporation inside the evaporator. So cooling drops off fast, and the AC can't produce cold air. This usually happens when the system is over-lubricated and must be corrected to restore performance. The blower pushes air through the cabin, keeps it circulating, and drives airflow across the evaporator so cooling can happen. It's usually tucked inside the HVAC module behind the dashboard. Dust and debris in the vents, or a dirty or missing cabin filter, can easily cause problems. Electrical faults or a burned-out resistor can cause the blower to work only on high speed, since it then gets full battery voltage. Electrical faults or a failed control unit can trigger issues, and the OBD tool should flag the error. A clogged cabin air filter chokes airflow, hurts AC performance, and can even overheat components. Dirt, debris, or a worn filter are usual culprits, so replacing it regularly keeps the system healthy. AC systems use different oils depending on the refrigerant and compressor type. Mineral oil works with R12, PAG with R134A, and PAG-YF with R1234YF. POE and POE mixtures support electric or hybrid compressors, while PAO offers a universal option. An ideal UV dye should be co-solvent-free so it doesn't weaken lubricants or damage metals and seals. A concentrated formula saves cost and requires less product. Look for NSF certification, choose a dye that matches the system's lubricant, and stick to OE-approved options to protect warranties and ensure safe, lasting use. This leak sealer, which stays inert until exposed to oxygen molecules, is designed to fix tiny leaks in the AC system, usually between 0.2 and 0.5 millimeters, caused by corrosion, vibration, or loose fittings. You can also use it preventively to avoid costly repairs from unnoticed refrigerant loss. It helps reduce internal friction, cutting down compressor noise and vibration, and it includes UV visible dye to make future leak detection easier. A vacuum dries the system by lowering pressure, which drops water's boiling point so moisture evaporates at room temperature. It's also great for leak checks. Vacuum won't hold in a leaking loop. And because the system is under negative pressure, refrigerant is pulled in easily. Just remember, vacuum needs time, and low ambient temperatures slow moisture removal. Congrats! You're now an AC expert. Register in Nissan's NTC database to get your personal certificate, product updates, and access to even more technical insights. Plus, enjoy free access to self-learning modules. Just scan the code or visit nissans.com/NTC to get started. This is Pam Oakes, ASE Master Technician and Automotive Applications Engineer, and thank you for watching this edition of Nissan's Expert, Unlocking Insights with Pressure and Temperature Gauges.